In this video, I'm going to import some data from a JSON file and then do some into Mathematica or Wolfram Cloud, and then do some manipulations to pull out of all the data I want, and then I'm going to plot it. So I need to make sure that what I pull out is sort of simple numbers that can be plotted. So to make sort of a simple list of number pairs out of it. Okay, so let's first just look at the data. I have it here. I have it posted on my website, so it's a URL. And it's got the structure of starting with an object. So I had a previous video where the JSON file started with the square bracket. So it started off as an array straight out, but this is a different style of JSON file, which is starting with an object. And then that object has a property, US underscore GDP in this case. And then that is the array. And it's an array of objects of a year GDP, a per capita GDP, and then the percentage growth. And I'm going to be interested in the year and the per capita. That's the data I want to plot. And these quantities, the years pretty clean. It's a number, but the per capita is not. So we're going to have to deal with these problems. And there's a $sign in there. There's a comma in there. There's a space in there. So we're going to have to do some cleanup before it's, and then there's quotes around it. So we're going to have to clean up the data and then make sure it's understood as a number before we can plot. So that's going to be part of the game here. Okay, so first is just a simple import and where the file is located, in this case, a URL, Shift Enter, there is our data in there. Okay. Now I want to just do some initial playing with this data. So we see that it is a list overall. So that if we started with an object in JSON, so that became a list, and that list contains a key value pair, US GDP arrow. So that is the key, and then here's the value, which is then a new list, and then that list has more key value pairs of year GDP per capita growth. Okay, so that's how that. So we have a list of key value pairs. That's what was this object in JSON became a list over here. So it was an object here, and in Mathematica that became a list of key value pairs, and then we have a list of those lists, and then that is again the property of a list. So there's sort of a list within a list within a list. Okay. So that was all the data. So now let's just look. The first thing was in the JSON, there was an object. It had one property, and so the outermost list sort of has one element, and so I can get sort of inside a little bit by just saying GDP square bracket 1, and that's going to get rid of that sort of outer set of curly brackets. So I'm moving. I have the list within list within list, and I'm getting rid of sort of the outermost list just by saying GDP square bracket 1. So there it is. So now I have gotten rid of that outermost curly bracket, but I still have that it is sort of a key value pair, that US underscore GDP is being arrowed over to all this other stuff. So I can get rid of that outermost key value pair by using the method values. So if you have key value pairs and you say values, then you get rid of the key and you just keep the value. And there was only one value in this case, so I'm doing that outer one, that outer key value pair. And so now I got rid of, the first time I got rid of the outer curly bracket, now I got rid of that US underscore GDP arrow. I'm just sort of working my way in. Now I have a list of lists, and those inner lists are a set of key value pairs. And so now I'm picking out, there were several properties in those inner lists, and I'm not interested in all of them. So here was the first thing I did, GDP, square bracket 1, and then I did values, and now that is a list. And now I'm saying, and that's like a two-dimensional list. There are sort of rows and columns. And so I'm saying I want all of the rows and I want columns 1 and 3. I want the year and I want the per capita. So this is a way of me, I'm not getting rid of any of this structure, but I'm pulling out items within the structure that I want. I want all the rows, the first and third column. Okay, getting closer. That is still not something I can plot. All this internal stuff is still key value pairs, which seem to sort of wreak havoc with plotting. So the next thing I want to do is do another values. So I'm doing a values of what I just had, and that will get rid of those internal key value pairs. So that will be applied to all of these key value pairs within the set. Okay, I still can't plot, but I'm getting closer. So I have the year and I have the per capita GDP. Okay. Now I'm just showing here how to get sort of a piece of it. So I can say, here are my 2 columns, and I call that 2 calls, two columns. And I can extract sort of row 3, column 2. So that is picking out from this the 1, 2, 3, the third item, and then within that item is a pair, picking out the second thing of the pair. So I'm not doing anything with that, just sort of showing how this works. So that's a sort of a 3, 2. Okay. Now, the game I need to play is, I think I have overkill on one of them. This is a number. I'm going to pretend it's not a number because I've had that issue with JSONs in the past. So I'm going to make sure this is a number, and then I don't want to plot with the dates as themselves, but I'm just going to say, what are the years since 1960? So I'm going to subtract 1960. So I want to make sure this first element is a number and then subtract 1960 from it. The second one is the more problematic one. It's a string, and then I can't convert it from a string to a number very easily because of it had the $sign, it had the comma, it had the space. So I need to do some manipulation of the strings and then finally convert it to a number. And so I'm going to do that in a loop. So I'm looping over the rows of that. I have that list, and it's sort of a list of lists. I'm looping over the sort of the rows, if you will. The sort of throws me off a little bit from other programming languages, but the indexing starts at 1 here in Mathematica world. And the 4 is a method. So there are 4 components or 4 arguments to this method, and it's normal for looping in that. So the first one is an initialization. I'm starting my counter I at 1. I'm going up to including the length of that list, and I typed a less than and then an equal, and then Mathematica converted it into this symbol, and I'm incrementing by ones. And then the fourth argument is a set of statements separated by semicolons. So this is all in terms of the method, one argument. Okay, so here's the part I probably don't need. I am taking the first element of the, so the ith row, the first column, and that was a year. And this is me saying ToExpression, sort of in case the years had quotes around them, which they did not, but in case they did, then they would be strings, but the ToExpression would sort of convert it to a number, sort of cast it as a number. So that's a little overkill right now. And then I am subtracting 1960 from it. Okay, so, and I'm just putting it back in. So these ToExpression won't convert it. You need the sort of 2 columns equals the ToExpression 2 columns. That will, if I needed the converting, would do it. Here's the subtracting. Okay, so now, and you see that I need to like re-enter the result, but here's the old result, and you see there the 61. We see that it worked, that we subtracted from the year 1960. Okay, now here is the work I'm doing on the second elements, which was the per capita. This is a string replace, and I'm string replacing on that second element, the ith element, the ith row, the second column, and I am taking a $sign and replacing it with nothing. So I'm getting rid of the $sign. And the same thing with this less than or equal sign, this equal sign. I mean, this arrow is, you know, sort of a hyphen and then a greater than, and it becomes this arrow anyway. Okay, so this got rid of the $sign. Then I'm getting rid of the comma. Then I'm getting rid of the space. And then finally, it's sort of in a proper format that I can sort of say, now make it a number. So it won't convert to a number with these things sort of in the way. At least I don't think it will. Okay, so get rid of the $sign, get rid of the comma, get rid of this space, convert it to a number. And then outside of the for loop, this is the end of the for loop down here, I just say 2 columns to sort of spit it all out. So I can see that I've got what I want. And now I do have what I want. Okay. You got to watch that this form looks good, but I could get this looking good and still not have numbers, but it was that ToExpression thing that insisted I have numbers. Okay, so I've had in other situations data that looked exactly like this and looked good, and I tried to plot it and it didn't work. So it has to, you have to make sure that it is that what you've got are numbers. Okay, so now I'm going to plot the data. So it's just a list plot of the 2 columns data. I gave it title, I gave it axes labels, and then I named the plot GDP plot. There it is. I'm going to fit that to a quadratic polynomial of order 2. I could use find fit or linear model. I'm using, in this case, the linear model. So I'm going to use the linear model fit. I'm plotting the data. I'm fitting the data to calls. I'm fitting it both to x and x squared. So x is my variable, but I'm going to use in the linear fit constant, a linear term, a quadratic term. And here is the quadratic fit to the data. And then I named it GDP fit, and then here I am plotting GDP fit on sort of the same domain of data here from, should be probably be from 1 to 61, but it went from 0 to 61. And so there is, and I named that fit plot. And then I'm just going to bring them together. GDP plot was the data plot, fit plot was the fit of the, that plot that we just made of the fit of the polynomial order 2. And I'm adding here the displayed the fit equation. So I'm using that as an epilogue with an inset. I'm taking my fit and using the normal in it. So that will turn it into something I can display here. And then I'm positioning that displayed equation at an x of 20 and a y of about 60,000. And there we go. That's what I wanted to show you. So I read in some JSON. It had this different structure than the structure I dealt with previously. It started off as an object with a property, and then the array started. And so then I sort of read that in and sort of worked my way down to pick out, to get rid of some of the key value pairs and pick out the columns I wanted. And that was this 2 cols. So here was getting rid of that outer sort of key value pair. Here was me picking all the rows and the 2 columns I want. And values takes, we have key value pairs. It gets rid of the key and keeps the value. And so this got me very close to what I wanted, but I still had the problem that I wanted to subtract 1960 from the years and also deal with the fact that these were strings and not numbers. And that was where I came with this for loop. I couldn't manage to do it without the for loop. So if somebody knows a better way, please let me know. But so I looped over and converted the year by subtracting the 1960. I converted the per capita, getting rid of the $sign, the comma, the space, and then I could use ToExpression to get it to make sure it was understood as a number and not a string. And then finally I had a list of pairs, so ready for list plotting and then fitting. All right, that's what I wanted to show you. Thanks for your attention.